Let's go through Decode 639, Decode Ways II. This question gives us a string, and for the string, the kind of characters in it can be 1 to 0 to 9, and also star. The difference from this question with the Decode Ways I is that the character it have a star character, and this star can represent 1 to 9. It asks how many decode ways of it. So for this question, we also doing like a dynamic programming that if we already calculate the we use a DPI, right? Represent for the index I-1, the decoder counts. So we know this DPI will coming from, for example, the previous DPI -1 plus previous DPI -2, right? So our goal is to find this U and V number. So we also set a different scenarios for this character. If this is a star, right? If this star, then we know this star we can use 1 to 9 to decode. So we are for this kind of DPI -1, right? And we just if we already have a DPI -1 console will decode away at this position, and add a star, we can use star to represent 1 to 9. So DPI will add 9 times DPI -1. So the U will always be 9, right? And for if this is a star, and whether we can transit from the DPI -2 depends on what kind of value for this character, right? So let's say if this character is, for example, it is 1, then we can use 1 to 9 to replace the star. So if this is 1, we need to add 9 times DPI -2. And also, if this is 2, then star, we can use 1 to 6 to represent that. So that is 6 multiplied by DPI -2. And if the previous one is star, that means this star we can use as a 1 or 2. And if this is 1, we have 9 combinations of this star. And if this is 2, this will have 6 combinations of this star. So that is 15 multiplied by DPI -2. That's 9 plus 6. Actually, we can think another way. That is star. There are 16 combinations, right? That is for example 1 1 to 1 to 1 to 9, right? This is 1 to 9. So separate, right? So this will be 9 combinations. Sorry, what it means that for this one, if we represent as a 2-digit number, it has 15 combinations. We put that together. We cannot separate. That is star, right? This one as 1 or 2, right? So if there are 13 combinations. So 1 and 1 to 9, 2, that is 1 to 6, right? So this is when it is a star. And if just get this back. If this is not star, this this number can be 0 to 9, right? So we'll say for this number, if this is 0, then it cannot use this kind of DPI -1 because 0 does not represent a character. So if this is 0, then U is 0. Otherwise, if this one is from 1 to 9, then we can use DPI -1, then U is 1. So this is this character. And also, when this character is from 0 to 9, we need to try to see whether how many combinations, transitions we can coming from DPI -2. That is, we're trying to see, we'll see this. We'll see the previous. The previous character. This one, right? We call C2. Call this one C1. Okay. So if this C2 is 1, then we'll say 1 and this number will have another combinations. That is, we can transit from DPI -2, because for any number 0 to 9, we can have a number to decode this. And if this is 2, this character is 2, and we need to have the C1 to be smaller than 6, right? C1. Then we can transit from this DPI -2. And if the previous is star, and that means this star can either be 1 or 2 to make this one as a number. So if this is 1, right? So in what kind of scenario we can select this one as 2 is that if this C1 is smaller equal to 6, right? In that case, this star can select either 1 or 2. So we can have two kind of this scenario to select this star. So if this star and C is smaller or equal to 6, then this V will be 2 for this number, because we can either use 1 or 2 to replace it. And if this star and this C1 is bigger, equal to 7, then this star can only be decoded as 1, then this V will be 1. So let's begin to write code to this. So we are also say if S equals null, or S dot length equals 0, or S dot start with 0. we just return there. For those kind of scenario, we cannot decode. And let's see, char array equals this to char array. And we'll have n equals array dot length. For this kind of question, the number will be pretty big. And then it asks us to mod this kind of 10 to the power 9 plus 7. So we are going to use long as a DP. New long. We have an extra index. And we can have mod here, right? Static. So we'll say DP0 will be 1, which is for calculation, and DP1. Now, because the first character, there is no DP minus 1, right? So we need to calculate it ourselves. This one will have two kinds of scenario. If it's star, it can represent 1 to 9. Then if it's a regular character, just have one decode way. Of course, we can put the 0 condition to here, right? But we already have a common case here. So we just need to think about these two scenarios. So let's say array 0. If this one equals to star, then we'll have 9. Otherwise, we just have 1, right? And we'll have int I equals to I smaller equal to n plus plus. Yeah. We're going to say we are trying to have dpi equals v u multiplied by dp I minus 1 v multiplied by dp I minus 2, right? We're trying to find this u and v. We are going to have character C1 equals array I minus 1, and C2 equals array I minus 2, okay? So just as we discussed, if C1 equals star, right? Well, see, this star can always represent from 1 to 9. So U will always equals to 9. We can use a previous counts, and for current star, we can use 1 to 9. So it will 9 times dp I minus 1. So we'll say for C2, how many we can transit from dp I minus 2. That is whether the previous character, the C2, can be used in whether we can compose from C2 and C1 as a 2-digit number, right? So let's say C2. Let's say V equals if C2 equals 1, right? That means our star, we can have 9 combinations. Otherwise, we're trying to see if C2 equals 2, then our star, we can use 1 to 6. Otherwise, we'll say C2 equals the star, then we have 15 from the previous transition. Else, if this is not a star, we say U equals if C1 equals this one, right? If it is 0, then we cannot coming from the previous dpi minus 1. So that will be like this, right? So let's say V equals what kind of scenario our previous that is our previous is a star, right? If this is star and current C1 is from 0 to 6, then this star can represent 1 and 2. Then this V will be 2 because we have 2 combinations. So we'll say if C2 equals star and C1 smaller equal to 6 and 2. Otherwise, we want to see if C we have different scenarios, right? Like C2, first condition is C2 equals 1. Or what is another condition? C2 equals 2 and C1 smaller equal to 6. Or we need to bracket here, right? C2 equals to star. Then we have 1, otherwise we have 0. After this, we just return int on dpi. it seems that we are missing missing a princess. We need to have this. Mm. Should be DP in. We can also have an early termination, right? So we know if C1 equals to 0 and C2 equals to 0, we just break or return 0, right? And also for this kind of one, we can have the rolling array to to um, to get the space complexity a bit better, because we'll see for every n it only depends on n minus 1 and n minus 2, so we can have a size 3, and in this case what where we need to change is here, only here. And yeah. So the time complexity will be On, and the space complexity will be a constant space space complexity. There is some kind of error here. Like it's 0. So this. So if this C1 is star, let's try to see what's the problem here. This is okay. Trying to see this. It's okay. Have a arrow here. Okay, so let's say this is pretty fast. and also the memory is constant memory space, and all in time complexity.